Hey, welcome to the Mentored Engineer. I'm excited to be here. Made some progress on my PLC control system. As you can see from up here, we have our card on there now. You can see we got our tensioning device in the back there, so it'll always stay in the right spot and have tension on that cable, which is very important. Special shout out to Austin, who rejoined as a member. I appreciate that. And we are very thankful for everybody who is supporting us. And if you aren't, please take a second to like, share, and subscribe, and hit that join button. Help support make this dream a reality. So we had some issues before on our PID control. When we go to our PID loop here, we have our set point variable, the dark blue line, and then we have the actual point, which is this later blue line. The problem is that the blue line, when we launch, changes very quickly, and it was very noisy signal. So we wanted to smooth that out. You can see that here. See how it's launching? And then all of a sudden we have this weird thing where the present value just jumps up. Oof. And then the set point does as well. And I have to figure out what is causing that, because that is not good. So I ended up finding that what is causing that is a inconsistent formatting of my variables. So it was just seeing a large jump. So what would happen is the cart would eventually go on one side, then go on the other side, and then go on the other side, just keep going back and forth, really slowly for, forever. I let it run for a couple minutes, just like that. So you can also see the noise here in this signal, and that's just not good. So what was causing that was the noise is created by me reading in a bunch of points coming in using the PLC's CPU, which might not always have the right clock time, and it's coming in very fast. So seeing the difference between a high and low might get overlooked, so you might read 2 or 1 or none instead of the proper number. So how do we fix this? Well, what we need to do is use another high-speed counter to count the signals coming in from our profile. So our profile is a trapezoidal profile, so it's going to look like this, kind of ramp up, have a steady state, and then ramp back down, and then be at a low rate. All right, now it's outputting pulses, which is 50% on, 50% off. However, that's not what I want. So what I'm going to do is I'm going to count the number of pulses that come in, and that's going to make it look like this as it ramps up, and you'll see that in a second. Now I have my ramp in time a lot less than my ramp out, because I want a little bit of ramp in, then I want a large portion where the velocity is steady, and then it's going to fade back out. And at that point, when it starts fading back out, the cart and the launch dog are going to naturally separate. Luckily, I had an old high-speed counter sitting around, mainly because I blew out the outputs on it. Yes, there is a difference between 5 amps and 0.5 amps. So when it calls for, 0.5 amp, make sure you put a 0.5 amp fuse in. However, the counter still worked great because I didn't blow those up. So that will smooth out that curve nicely, and we'll see how that follows our data in just a second. So what I'm going to implement now is a stage gate system. So this prevents things from interacting with each other and allows the logic to be clearer. For example, when I first start my motion, I'm going to start moving this way. Right now it's only for 2 seconds, but eventually it's going to go this way and hit all the proximity sensors and latch those on. So I want to make sure that my high 1 and high 2 are active reading as a check, and then it's going to go all the way back and do that. So that's 2 stages. Stage 1 is moving this way till I hit both of the highs. Once I get both of those, I'm going to go to stage 2 and move it all the way back. So when I'm in one of those 2 stages, I can't be doing other things. All right, I can't be moving forward and backwards at the same time. I can't be launching at the same time I'm going backwards. We're not doing that. So it prevents things, so I can look at very precise things and see where those things are going wrong and troubleshoot them then. So when I look at my program here, this is the initial stage. It's loading some stuff. Here it's loading the high-speed counter. This is loading the analog inputs and outputs. Here it is setting the e-stop check, so we're always going to check that. It's going to check, put our set point in there. And at this point, it's going to jump to our initial homing. So here we reach the e-stop check. We're going to be looking at our 2 e-stops, and here's our second one on the panel. Put that on. And at this point, our e-stop out would be okay, but I bet I'm in program mode. Yep, so that's not going to work right now. We're then going to be looking at our proximity sensors, and if any of these proximity sensors are high, it's going to latch those on because we're going to be going past them very fast, and they may not trigger automatically, so we're going to, once you see a pulse, hey, latch that thing on until something else breaks that. So here, if we see our home prox is on, and we're not launching, it's going to be latching this on, and then that latch will stay on forever. Until, of course, we are launching, and that'll release that. So here in the initial homing position, I can press this button, and it's going to start doing things. It's going to start this 2-second timer, and it's going to tell it to go this way and to output a signal up here, and then to latch it on. So it's going to go this way 2 seconds. Now eventually I'm going to have these 2 switches reset it. So I have to hit these 2 switches. And at that point, it's going to go, and once that timer is high, it will go to the next stage, which will be to reverse direction and force it back this way. And it'll run until it hits the end of the proximity switch, which is monitored and right here. There we go. And then it will go to the next stage, which is stage 32. In stage 32, we're going to move off that prox switch, and we basically tell it to turn on your PID. And then at that point, it's going to go ahead and start an 8-second timer. It's got 8 seconds to move there. And eventually there's going to be a proximity switch there that'll verify that. And then at that time, it'll be ready to launch. When we're ready to launch, we enter stage 100 here. We load up that trapezoidal profile I was talking about. You write it into the memory. And then we got a whole bunch of stuff here, but here's the launch button. Once that goes and our e-stop is okay, we're going to start outputting data. We're also going to read in our high-speed counter right here and write that to the track set point. And then once we have over-traveled, we are going to go ahead and set a 4-second timer. It'll probably be more closer to 6 seconds in the real version. And then it will activate a jump back to finding homes. So as soon as it finishes launching, it'll wait a few seconds and then go back home. All right, so let's see this actually work, right? All right, so we're gonna go ahead here, put it into run mode. All right, we gotta put our panel e-stop back on. Bloop. And now we've got our e-stop okay. All right, let's scroll down. We're waiting to home right here. Let's go ahead and hit the home button. Now it's going to go this way. 2 seconds. Now it's going to reverse. Hit the end stop. And now we're in stage 32. And it's coming off there. And then after 8 seconds, you just heard a click. It shut off. So now we're ready to launch. So let's go here to launch. And this is the launch stage. So let's go ahead. We're going to hit the launch button. It's going to load the profile. Hopefully this will be successful, and it'll launch. And we're launching! Ah! All right, now it's going to come back. Obviously, it's going to have to be a little bit faster than that, right? And now it's going to back off the proc switch. And we're ready to launch again. All right, now you can see here our data. That blue line is a lot smoother than it was before. So let's go ahead and launch. And we can see how closely our output monitors the input. Or vice versa, actually. All right, we overshot here. And now we're coming back. So you can see it stepped down here. That's just because the CPU is in manual mode, so it's not cycling as fast as it normally would. It's cycling about once a second or something where it's updating. You could see that the speed coming back was smooth, so it wasn't really an issue. All right, well, that's where we are. Next stages, we're going to get some proc switches up here. We're going to have one that makes sure that we got to the home position so that we know we're in the right spot when we go ahead and put the launch dog up. We also need 2 high side proc switches on this area, so we're going to be installing those. We need to clean up the wiring in the box, and then we need to add those new proc switches to the ladder logic and interlock stuff and throw in some error warnings. So that's a lot of next steps. That'll be in the next video. Hey, thank you for watching and have a great day. Please take a second to like, share, and subscribe. Adios, Captains!